Hello, everybody. Appreciate you jumping in. Um, I'm sure many of you have attended some of our webinars in the past. I'm excited to run through another one with you guys today. Today we're going to be talking about our MPack 261AC or 261A. We're going to dive into a little bit more depth of the product itself, start talking about some of the complexity with it, some of the value that it brings, and the different kind of flexibility that it has compared to some products we've seen in the past. Feel free to drop any questions in the chat. We have the team monitoring it as well. So if anything comes up, feel free to ask and we'll address them as we move through this. With that, I think we'll go ahead and get started. We'll start with a little bit of an overview. I'm sure many of you have seen some of this before, so I'll move through it pretty quickly as we get started here. Um, in terms of just who we are as a company, Ren has been around since about 2014, have grown a very wide global brand at this point, very focused on battery technology specifically. So everything from storage to EMS and BMS design, both on the hardware and software side of things. So very familiar with the technology. We hold, as you'll see, we have a lot of products coming to market. Our core focuses are really around residential, commercial, industrial, and then now in the growing EV space, we're doing more battery buffering, and DC fast charging. And we're very excited about some of the portable energy storage solutions that are coming to the market a little bit later this year. So there's some exciting stuff, and I'm aware some of you are familiar with a lot of these different products and have used them in the past. If it's your first time in here, I'm excited to share more about some of the different things we can do. Again, today is going to be a deep dive on one of our CNI solutions, the MPack 261A. So if you're curious to learn more about any of the other solutions you see here, residential, DC fast charging, or portable, feel free to reach out, or even some of our utility scale stuff that's at the megawatt scale. Feel free to reach out and we can connect more directly. As I had mentioned, we have a very global footprint. Renon USA is the current brand that we're a part of here. We entered the US probably 3 or 4 years ago, but really reinvested and put a lot of effort into growing the US brand last year and are now developing a manufacturing facility in McKinney, Texas. Um, it's going to be a 3 gigawatt annual capacity manufacturing facility, so definitely quite sizable. We're looking to do both residential and commercial battery manufacturing out of this facility. As a result, we will be both FIAC, BABA, and domestic compliant by probably Q2, I would say. So we're still kind of new on nailing down some of the nuance in terms of company structure. We are FIAC compliant. It's just a matter of the domestic manufacturing to make sure we get all of the parts and pieces squared away. We are a veteran-owned and disabled veteran-owned company. And we are really leveraging our global experience to bring the best of the technology and storage of energy storage to the US. As I mentioned, Paul Buckwater is a disabled veteran, and he has a long-term experience in the field and has run this company for the last 2 years as the president and owner. We have our management team. Jane is our GM. Josh Brown from the residential side of things. Jose runs our FAE and any kind of post-sale ongoing management and support of the products. And then Pablo Vial is our director of marketing, and then myself for product management, as well as growing our department of customer empowerment. So responsible for hosting a lot of these webinars, anything in terms of custom product development, we'll work very closely with you on when it comes to general product training and also product delivery, project delivery, making sure we have everything squared away and fully finalized in the full delivery scope. As I mentioned, we've been growing since 2014, bringing us pretty quickly into the modern era. In 2024, we had our partnership with Solarc, which really kicked off our launch into the US markets in a much more powerful way. Um, we've seen a lot of market adoption of our products, especially in 22, 23 in the Japanese market on the DC side of utility scale support. And we're doing more and more of that now. So in the US market, the product we'll be talking about today is really designed and optimized for this utility scale kind of support and optimization. As we're moving into 2026, we're excited again about the manufacturing facility that we have coming online, in addition to a lot of the new products that we've kind of revamped and are bringing to the market. Quality is always at the core of what we're trying to develop and deliver. We follow very closely the quality management principles, try and hold to the Six Sigma standards for manufacturing and make sure that there's no issues or errors in any of the things that we manufacture. And as a result, we also have a lot of patents, both on the software and utility and application patents. From multiple sides of things. So I really make sure that we own the technology, we have a very thorough understanding of it, and we provide unique and custom cutting edge solutions to our customers. Um, Digging into the core technology a little bit more. So let's do a quick review of kind of the high level operations of our technology, and then we'll get into the specifics of the product that we're looking at today. That's going to be the MPack 261A. The biggest thing that we think we bring to the table is our EMS technology, and this is included in all of the products that we ship. We have both the local, so there's kind of three tiers to the EMS technology. There is the cabinet level, which supports the operations of the battery itself. So it's where you're going to see all the fire suppression and safety technology. So I'll talk about that a little bit more here later in the slide. And then that scales up to the array level, which is very relevant here for the 261A. And we'll talk about that again a little bit more down the road. And that allows you to kind of do coordination, make sure all those cells are charging evenly, able to strategically distribute power from them in a tactical way. And then finally, you have the station level EMS. All of these kinds of different tiers of EMS structure bring different advantages to be able to have the right level of nuance and control over the products that you need to deliver. We have the ability to integrate, open our APIs to external utilities, to any external control systems. If you have an external third-party EMS that you'd like to use, sometimes people have 10, 15 different like kind of IoT technology that wants to communicate with a lot of different smart products. And in those cases, sometimes leveraging an external EMS is the right choice. We also support VPP or virtual power plant programs, as well as grid integration. Um, this allows you to turn these otherwise cost savings or cost mitigation or backup tools into actual revenue generation by participating in demand response events. Or a lot of the time, if you have somewhere that has unstable grid infrastructure and you have critical equipment, you can have these kind of support at the grid level to provide resilience to whole communities. So we're seeing some of that application actually in some South American and Central American markets where there is way too much solar during the day and then they're running diesel generators at night. So that's the perfect solution to just add some energy storage in order to mitigate that and distribute the power a little bit more. Um, this is as I had mentioned, in the cabinet itself. So it's a little bit more of the local EMS technology, digging into the actual features and controls. You can do edge computing, which is what I think a really cool component here. So you don't need to be continually connected to the cloud in order to apply the logic for charging and discharging these batteries. We have flexible scheduling and automation. You can either tie in external meters and CTs in order to control charge and discharge rates, or use the built-in on the actual EMS inside the cabinet. There's going to be an LCD display screen that you can use to set charge and discharge timing, a whole bunch of different control systems. This all scales up to this shows up as the prime control. So this is what's in the actual cabinet. When I mentioned there's an LCD display screen, this is what you're going to be interfacing with. So it tells you in real time all the cell voltages. It gives you a state of health of the entire battery. It allows you to set the parameters for the PCS to charge or discharge, and then charge and discharge rates. Whole bunch of different settings that can be controlled out of this. Now, this is the Prime Control Base, which is the station level EMS. And I'm excited to share that this is actually getting a pretty big facelift and revamp. So we're in the process of kind of redesigning this EMS system to improve it to give a lot more functionality and ease of user experience. It'll allow you to not only monitor functionality of all of the different products that you have distributed in the field, whether they're in a single geography or they're spread over an area, but it will also allow you to actually, we're working on incorporating a little bit more uh, ROI or kind of revenue validation technology in here. So we want to be able to monitor the equipment, look at how it's utilizing and distributing energy, look at your energy agreement, and then be able to very effectively state this is what energy you are saving, or this is the cost savings and cost reduction as a result of the investment that you've made here. So it's all part of a new initiative that we're taking to really refine our product project delivery timeline, and just like what the scope of that project delivery experience looks like. So from the get-go, looking to support the uh, project design and layout, make sure we have all considerations captured and understood, make sure we thoroughly understand the customer's intended use case. Um, all of these kind of tied together to provide the insights that we're looking to capture here. And then once a project gets installed, making sure we provide commissioning guidance, do a validation of commissioning received at the roughly the 30-day mark after delivery. At the 60-day mark, make sure that things are operating as expected, that it's in the expected use case. And then finally, at the 90-day mark, do a kind of value creation review to make sure that we're creating value for the customer in the way that we expected and that they were looking for. The safety technology, this is really what goes into the uh, local level EMS, so at the cabinet level independently. This digs in, this is what monitors all of the fire suppression and safety and control systems, as well as the individual cell temperature monitoring, voltage controls, any errors or fault warnings. The nice thing is that if you have a fault from, for example, a blip in the energy production that might cause a cell to temporarily trip, the EMS is capable of self-monitoring. It'll continue to like cycle and do a fault clear if to validate that there's nothing that is an ongoing issue. So it's kind of nice that you don't have to do a truck roll every single time a fault trips. It can kind of self-clear and re-mitigate some of those issues on site. So with that, we did kind of move through a lot of that very, very quickly here. Let's dive into the actual product itself today. I want to start by kind of going over some of the basics of the product itself, and then I might even jump out and dive into the user's manual just to kind of give some nice depth of context here. Um, so this product, the 261A, actually comes in a few different configurations. So the base 261 comes with a Synexcel 135 kilowatt bidirectional PCS. This product as a whole is an upgrade from our MPack 233, which many of you might be familiar with, and is kind of our more standard product offering in from 2025. Um, with this product, you'll notice that not only did the kilowatt hours go up, so it's no longer 233, it's at 261. We changed to a Synexcel PCS from what we were using previously. The major advantage that this brings actually is the rather than it being a 480 Delta native configuration, it comes out 480Y. And just having that neutral line removes the need for the isolation transformer that has been a part of all system design for the 233. So that upgrade is a massive improvement to the quality of the product and helps prevent the need for additional isolation transformers. And it provides load balancing from the get-go right out of the PCS. So as a result, it gives a lot more flexibility in terms of scalability and diversity of application without necessarily needing that isolation transformer. You can do 5 of these together to perform one array. So that's essentially when you have 5 of these units, you're at a megawatt scale, and that will what would create what is referred to as an array. That array can then actually be stepped up through a transformer to support grid level voltage of 15 kilovolts and even up to 35 kilovolts when we really scale this up. And we'll look at that in a little more detail here. It's still a liquid cooled system, and it operates using the same multi-level EMS array that we just talked through. It has some very sophisticated safety architecture. It has aerosols, smoke monitoring, temperature monitoring, dehumidifiers in there, a lot of stuff to make sure that these cells are kept at the uh, optimal range and operation. And again, that modularity is really a major advantage here, being able to scale from a single unit to an array to the full matrix project level, depending on the need of the utility or the scale of operations. So major highlights here. It's directly intended to save on the cost of electricity, even if you do it without solar. So even without any PV systems, um, it can provide value simply through energy arbitrage. So a lot of the time you'll have peak charges in the 5 p.m. to 9 p.m. window, whereas the energy is much cheaper from 1 a.m. to 5 a.m., right? So it gives you flexibility to charge at night and then discharge during the day when it's most expensive. Or even if you aren't looking to use this energy and you have a very low energy cost location, it can be used just as an investment structure by charging at the cheaper rate and discharging at the higher rate. It's a direct mechanism for energy arbitrage. So you can make 20 cents on the kilowatt hour every single night when you're running, if you were cycling this thing every single day. So, um, depending on how many of these you have and the scale of it, if you're making 20 cents per kilowatt hour and you got a 261 kilowatt hour battery, um, yeah, you're running a couple $100 a day. In time, in time. That's a little bit of a high assessment. One other thing that we really pride ourselves in, and one thing we focus on as a brand as a whole, is that everything we ship, we want to be plug and play. We want to be able to drop in a battery on site without having to have a long and extensive construction period. If you've seen stuff like the Tesla Megapack or Sungrow or some of the other major players in the utility scale solution, they drop a container on site, but it's a shell of a container. And then they have to separately ship the cells. And then you have a team on site to do the installation of the individual cells within that container. So, as a result, that really extends the difficulty and complexity of the installation process. We love having a product that we can just ship, drops on site, and it's a plug and play solution. You wire a few of them together and then you get some more additional power out of it. So a lot of really time saved on the construction side, which can often be a major cost. Having an entire team of 5 to 10 people on site for 2 weeks is a major expense compared to having a three-person team on site for 4 days. So a lot of advantage there. And if it's your first time installing any of our CNI solutions, we'll provide on-site engineering support free of charge for first-time installers. That kind of ties into the complexity and the grid connection. This product especially, and several of these of our products, when we have an engineer on site to do grid connection and grid validation, we can do grid validation connection in a 24-hour period. So if we have one person on site and the system is fully installed and commissioned, in order to validate the grid connection, we can have support on site to get that done very quickly. Very little wiring is required. It's very nice. It's very handy that it is all kind of built into that internal EMS screen, as I mentioned. And then to have that also extend to a cloud platform you can operate and interact with without having to be on site is another major advantage there. So there's several different applications that you can look at for this kind of product. A lot of the time, we'll look at some for CNI projects where they need the resilience, whether they have cold storage, like a grocery store, medical facilities, pharmacies. A lot of the time, they need to have fridges that are able to keep the medication at the right temperature. And if there's a grid outage for even 30 to 40 minutes, there's major losses there. So having the resilience is one massive use case for critical infrastructure, critical projects. That's also the case often in the manufacturing space. If you have the product line go down, or if you have the manufacturing line halt for even 30 seconds, half the product that's on the line, maybe it's temperature sensitive, maybe it's process and positioning sensitive. So if you even have the line stop for a second, sometimes you have to clear, trash the entire everything that's in production on the line, and then reassess it. So not only does the stopping halt it, but you're also losing 3 to 4 hours of production time getting it reset and up and running again. So resiliency is obviously a major advantage there, just to cut the risk of of losses due to energy loss. CNI parks where you have just high energy cost and demand, again, that mitigation opportunity or arbitrage opportunity, being able to couple it with PV, charge during the day, maybe you oversize your PV system a little bit so that you're producing more power during the day than you consume. That allows you to charge up your batteries and gives you resilience to be able to discharge those batteries overnight. And we can talk about different sizing strategies there in terms of how you want to make sure you have enough PV to offset the amount of consumption while giving you enough to charge your batteries, and then kind of figuring out what that right recipe is in terms of overnight. If it's a three-shift kind of facility, how do you decide what the right amount of PV and the right amount of power is? Public charging stations, as I mentioned before, it's kind of cool with this product, the MPack 261A, is that it's flexible. We do have a explicit version of this that includes a DC fast charger. However, you can integrate this with existing EV charging pollards, and that still gives you the advantage of being a battery buffer because one of the major components of cost is instantaneous demand charges from the grid. So that's going to be a rate at whatever the single highest power draw you hit throughout the entirety of the month. If you hit that power draw even for a minute, that is going to be your rate for your demand charge for that entire month. So we've seen a lot of people reach out from a lot of dealerships, like car dealerships, Ford especially, that recently introduced EV cars for the first time, and they put a Pollard or two on site, and then all of a sudden, one person charges their car for 20 minutes a day, and their power bill is twice as much as it was previously, because those demand charges are just crazy high spikes. So by putting a battery on site, you're able to trickle charge that battery or charge it at whatever nominal rate. We actually have the ability to do smart charging, so if you would tie CTs elsewhere in your system to monitor what the total system energy consumption is, we can tell the batteries not to charge unless you are 20 kilowatts below your standard peak threshold. So just to make sure that we're only ever charging when there is not other load on the system. So that's another nice perk there. But as a result, it really is down in your um, peak demand charges. They're also to be able to do that intentionally by discharging when you have high demand charges. Maybe you're doing like a testing facility and your test is very high energy intensity. So for 3 hours once a week, you are doing a massive power discharge in order to do some scientific testing. And in those circumstances, having the power, having a megawatt of storage and an extra 500 kilowatts of power can significantly reduce those demand charges that you see for those brief and sharp periods of time. Um, these have even been used in some commercial complexes, both for individual, like for um, retail or for even some residential spaces. So if you have a development of a community, we're seeing more and more smart community development that wants to have a kind of centralized microgrid that's still tied to the grid, but minimizes its dependence on the external grid as much as possible so that roughly the entire community doesn't really get a major power bill, and then the developer has the flexibility to then continue to charge your standard power bill rates to the homeowner or provide it as a value to increase the value of the homes. So just more and more flexibility that you get in all the different ways you can apply these batteries, and it's kind of fun to get creative and think about all of the different revenue models that come with this kind of stuff. And then obviously microgrid projects when you're tying directly into the grid. This is something we're seeing more of in South America and Central America, where grid infrastructure isn't really strong. They're facing challenges of trying to decide whether or not they want to build new power plants. Their power plants are, they would need X amount of investment in order to do so. They have a lot of PV, but it only helps them during the day, and then the grid is really struggling in the evening hours. Those are when having a larger, multiple arrays of these 261As is a really good solution in that you have a string of five sets of five, those all tied together and then go through a step-up transformer and can actually provide that 35 kilovolt power to the entire grid and essentially subsidize the amount of demand that it can provide to really support an entire grid stability and infrastructure. This is also another application where we'll see energy smoothing being done. There's more and more in data center applications. People are trying to leverage existing resources to try and generate some power on site. However, power generation tends to be pretty chunky and unsmooth, and you have when you have data centers or really critical equipment, you need it to be smooth and consistent power distribution. So we've seen some people that are like putting in a site next to a hydro dam, and the hydro dam might have fluctuating power generation depending on water levels, rain, storms, or even just blips in the cycling of the motor. So having a large energy bank to be able to smooth and distribute that really makes a big difference. Looking into a little more detail, let's kind of dive into some of the internals of this battery itself. So as you can see here, we have the five cells of the battery. So there's actually five individual packs that make up the 261 kilowatt hour cell as a whole. These all tie in series in order to get the voltage up to operate at that 480 voltage range. That's going to flow into the PCS, and that PCS is going to be the main control system. And then that connects to our BMS, so the battery, the actual like brains of the system. So we have the BMS down here, which is what flows all of those batteries into it. It kind of does the central coordinating. It measures and monitors how the data is flowing between all the different cells. It's what maintains the communication and cell monitoring, as well as temperature monitoring of all of those different systems. Um, and then that flows into this PCS. This is the Cell 135 kilowatt PCS. And this actually is you can see the four wires here, so four hot lines and one neutral line. And that is actually a little bit misrepresented here. There's actually four lines that are the output from this PCS system. So it gives a lot of flexibility. Having that neutral line really improves the flexibility of the system, improves the safety and robustness of it, and also helps protect the equipment. Two things to consider here. There's two additional add-ons that can be done to this MPack to improve its functionality. We have an optional MPPT uh, cabinet that goes on the side. So any individual cell can have an MPPT cabinet that goes on the side, and that adds is capable of supporting 120 kilowatts of PV. So one single 261A is capable of supporting 125 kilowatts of solar. That's pretty nice to be able to have that tied directly into it. It really simplifies the system. You're then leveraging the reason that threshold is 125 is 120 is because you're leveraging the inversion of the 135 Cynic cell. So that MPPT cabinet is going to match the voltage from the solar to the intake of the battery. And as a result, the BMS will then push that to the cells to directly charge the cells. So you're getting a little bit less loss. You're not going from DC on the solar production through an inverter that's then flipping it back to DC, flipping it to AC, and then back from AC to DC to into the system. So a little bit more efficient when you run it all together in that kind of process. Um, so that's one option to add on here. And then the second option is a full STS system. So the STS is nice because you can actually do, I think, two of these batteries per STS system, and that really provides instantaneous changeover. So with an STS, you can have a true uninterrupted power supply for up to the 500 kilowatts, or sorry, yeah, 500 kilowatt hours, 100 and roughly 160 or sorry 260 kilowatts of power for instantaneous changeover. So that's really really nice. We're seeing that more and more in hospital applications. Again, some on the data center side, but places where you have really critical infrastructure where if the light even flickers, I heard a hard story about some hospitals that have typically relied on diesel generator backup. So when the power goes down, the generator kicks on, but it's like a 3 to 5 minute downtime. And if someone's open on a table in surgery or if they're on critical life support, I was discussing with a client who's looking to apply some of our STS solutions in the Texas region where in the last year there was a hospital that had like a 3 to 5 minute outage and it caused the loss of life of four patients there. So really, really critical stuff to make sure you have energy when you need it. So the STS that can be added on the side here is a really critical module and provides a lot of value and flexibility in terms of making this product exactly fit the needs. The reason that's not by default integrated is because sometimes it's not as critical and it is a cost adder. So there's the flexibility to say, is this something we need instantaneously? Is this something we don't? What's the value that it provides to us and how can we leverage that? So there's a lot of advantage there in doing so. This just kind of gives you a picture of some of those different on-grid, off-grid switching load profiles. So the way that this is wired up, you can have the MPPT cabinet. So this would be an example of the model with both the MPPT cabinet added and the STS added. And you can kind of see them in the graphic here. They're not really depicted in the top one, but here you can see the solar would then run directly into the MPPT cabinet. MPPT cabinet would then directly DC charge those cells. Those cells are then connected through an STS to the load. So it's 2 units per STS. And when we have that STS operating, the switching time is less than 20 milliseconds. So really, really rapid changeover time. That tends to meet the threshold for some of the like critical computing stuff. Some smaller UPSs are still needed on like a server by server basis if it's like a requirement of 5 milliseconds or less. So we see some flexibility there, but in terms of human experience in an operating room, in terms of a facility like a hospital, as I had mentioned, they're not going to see the lights flicker. That's going to be a really, really rapid changeover, and it is a true STS, which is, I think, a really rare opportunity to find integrated into the equipment these days. Moving to the utility scale, so when we're not as concerned about that STS or that on-off grid switching, but we're really looking to support larger scale utility operations, um, the you can have these arrays set up in arrays of five that then tie into either a 10 to 15 kilovolt or a 30 to 50, 35 kilovolt scale. And this is really dependent on the transformer or on the scale of the operation needed. Um, this can also tie in external solar as needed. So a lot of flexibility to, as you can see here, we have the four arrays can get up to that 15 kilovolt range, and 12 can push for that higher voltage ranges. And this is like true transmission voltage ranges. So this is for if you want to have a utility support kind of dropped out in a remote location that has some additional space for it, where it's easier to do this kind of energy production or energy storage at a lower cost in terms of the land, and then still want to transmit it and support that full grid level operation. This is a similar approach, but kind of broken down and having the solar tied directly in. So you can have a separate, this kind of maps out on the right hand side here. You'll see that there's the separate solar inversion that then ties into a transformer, and then we're just kind of grid tied to the same operation that the solar is providing from. In this kind of circumstance, we can use some CTs and we can try and do some complex monitoring to make sure that these are charging when solar is producing, so that there's like a downstream CT that we're trying to monitor and minimize power flow through. Whereas this approach allows you to have much more direct control over that. The solar is flowing directly into every individual module, and then those individual modules will then be gathered and grouped and then stepped up to support that grid operation. So uh, again, the modularity of not including the MPPT cabinet on every single model, but having the flexibility to add it or not have it, really gives this the ability to be the nuanced solution that is what you need it to be, and at the right price point for you. So you're not paying for what you don't need. Um, again, we shipped everything fully assembled. It's a little bit more of a high level review here again. Everything's fully assembled on the product. It's really easy to just drop on site, wire it up, pretty easy, quick to go. The installation's very, very simple. There's an internal bus bar, parallel connections. It's very, very quick in terms of getting everything wired up. We can have an entire installation and commissioning in like 2 days. The commissioning is self-recognizing in the EMS. It kind of self-checks, runs all those things, and it, like we said, is plug and play ready. Um, in terms of getting grid connected, if you really are trying to do that step up to the 15 kilovolt, we can have support on site to do grid verification and protection testing. That's it tends to be a little bit more rigorous. A lot of the time, utilities will have their own um, jurisdiction or their own engineers and a lot of their own constraints in terms of making sure that it's robust and safe. So we are always delighted to provide the support in order to do that. And then obviously there's the cloud and EMS system that we've talked about pretty thoroughly at this point, that gives you the ability to monitor, remotely control, and then work flexibly with all of these applications here. In terms of the core service models and what's really required for these guys, there's very little preventative maintenance. There's a lot of internal monitoring that will say, hey, there's anything going on. Um, there's the on-site support. We always have the ability to get engineers out there if you need to. We have a very good, as you had mentioned, as I mentioned Jose at the start, we have a very good FAE team that's capable of getting on site. They're traveling regularly to get where they need to be. This product has a base of a 5-year warranty. You can extend that warranty by 10 years for an up to 15-year warranty, with thresholds of operational range at the end of life. So, a lot of value advantage in terms of making sure you have a product that will last that long. There's a lot of different response mechanisms in order to monitor whether or not it is a small, simple fault that tripped that it can then self-clear and continue operation. Um, some require remote intervention, so we need a third party to say, hey, this is happening. Maybe we need to change the operation processes, and as a result, can clear and get it operational, or we can get somebody on site and make sure we get it taken care of in a pretty quick and operational way. As I mentioned, part of this core service model that we're moving towards is being able to validate the ongoing value that we are creating for our customers. So that's kind of the customer enablement and training that we're looking for. So when we have a project with any one of you guys, we will have uh, the discovery. So we just understand what you're looking for, what you're trying to do. If you're just trying to understand our products, we'll kind of put that in one category and make sure we have any questions you might have processing, and then come back to them. If it is something that's project specific, we will open up and launch kind of a project intake form. We'll start documenting all, whether there's PV involved, grid tied, on-off grid requirements, switching times, expectations. That'll allow us to kind of create a recommendation in terms of energy storage profile, what types of equipment we would recommend, different options in terms of approaches, cost thresholds, larger scale, lower scale, whatever you're looking for. That then turns into, once accepted, and we've kind of cleared that this is a purchase that has been validated, deposit's been received. We'll then put together a commissioning guide packet for you. So, what does installation look like? What are you going to need on site for this specific project? It's not just going to be generally throwing our manuals in there. Obviously, those will be included, but we're looking to get more specific in terms of what region are you in? Is there any additional commissioning notes to pay attention to? Let's pin down specific dates for this that we are expecting to get this installed and commissioned. Do you require on-site support to do so? So the entire commissioning preparation also comes with training where we'll say, hey, here's an installation video, review these things. Let's have a call prior to you doing that to make sure we can answer any of your questions that came up in doing that video. And then finally, once it's installed and commissioned, we hit that 30, 60, 90 approach where 30-day mark, we make sure commissioning and installation went smoothly. 60-day mark, we check in on operations to make sure it's behaving and you're getting the support out of the product that you're expecting to. And then the 90-day mark, doing a bit of a financial validation to make sure that you're getting the value that you expected. This product fits into a bunch of different business models. Whether you're an energy investor, someone that's looking to do more arbitrage, support a utility, buy when it's cheap, sell when it's expensive, that's one approach. As well as kind of aggregators or VPPs that are kind of doing something similar, but with a slightly different lens, being a little bit more tied into the demand response approach. Um, Focusing on fluctuating energy rates in order to very quickly and actively respond to when there's demand events. You saw some less than ideal application of this in the like Texas a couple years back during the ice storm when power was down. The few people that still had power had exorbitant bills because there's like shifting energy rates. So having some protection from that is a major advantage, or being able to leverage it in less extreme cases is still provides a lot of flexibility to aggregators and investors. EPC companies. So these are those that people reach out to you looking for solutions, and you're trying to figure out what the best solution is. We love working with EPCs. They always have really thoughtful engineers, really robust engineering delivery. A lot of the time, I mean, pretty much any time on a project, we can provide example single line diagrams of projects that we think are very similar to yours. And then if you provide single lines from your EPC company, we can kind of do a check over and say, yes, this looks like how we would expect it to play out, and this looks like the right approach for this particular project. And then obviously end users, those that have the need. This is what we're seeing more of from the kind of Central and South American regions where they just, hey, I'm an individual as a business owner, a manufacturer. I'm struggling with these problems and we need some support. So, a wide variety of business models that fit into any one of them. Hopefully, anybody here sees yourself in one of these categories and sees the value that we can bring for you guys. I'm going to kind of quickly move through some of these, a couple different examples of case studies, and then try and open the floor to questions here before we run too long. So this is an example of essentially dropping a couple of the MPack 261As on a remote highway service site. So it's somewhere where there might not be a ton of grid infrastructure. There is some power, but it's expensive because it's remote and there's high transmission costs. They have to run way down lines to get to them. So by installing some solar panels and some storage, this can meet the growing EV commercial need. So when EVs are in remote places, they have a premium that they can charge at times, and as a result, there's more financial opportunity there. So this can be a multifaceted revenue generation approach. You can make money from or reduce costs from cutting down your transmission and demand fees coming from your utility scale. Um, Lowering your own power bills purely on a consumption basis, just because you're using less from the grid when you have solar and an energy array. Demand response will likely drop because you're able to reduce the amount you provide power, so your total peak power consumption will drop. You can participate in demand response events as well. If for whatever reason the utility that you're a part of has an event where they need to discharge and could use power, um, you have excess energy in these BESS systems, and you can discharge back and actually receive money from the grid. And then there's also tends to be some carbon offset revenue, potential tax benefit and advantage. So all of these kind of play together to create your total ROI on a project and to give you what your expected return is over time, and how soon these systems will pay for themselves. And it's kind of nice to have so many different levers to pull. Also, depending on potentially the local jurisdiction, if there's any, or if there's the local utility programs, there might be some incentives to reduce the cost of these batteries in the first place. So, a ton of different levers to look for when trying to figure out how to make these projects financially pencil out. And there tends to be ways to generate revenue or reduce costs in more ways than you expect at first glance. The way a system like this might operate, and you can actually get up to some pretty high scale systems here, is that you can actually run these batteries in the array level. So you have a set of five of them per array, as you see here. And then each array of five can then be blended into what creates a matrix. So then this allows you to, even in a very remote place, have megawatts of storage using this device, using these batteries, because they don't really have a maximum parallel limit as long as you're operating at the five cabinet per array structure and then the arrays into matrix. This is exactly what our EMS is intended to do in order to build and scale up to this level of operation, which is really impressive. So it gives you a ton of flexibility as you grow and expand to the level that you need it to be. And this applies as well for some completely off-grid applications. We have a project that we're looking at out on Fiji where they have a luxury hotel on an island that has no otherwise has no power infrastructure. Um, so there's not even a grid to tie to. It is completely off grid. It is all generator operation. And by leveraging this kind of equipment with a solar field, you can start by just dropping these batteries on site. And even without any additional solar, you're reducing the amount of time you have to have that generator running. Because most often, when a generator is running, not all of the power that it's generating is being consumed. So, this allows you to run that generator for shorter periods of time, store the excess energy, and then discharge it. So, maybe late in the evenings or early mornings when you want it to be a little more of a peaceful environment, you try and charge to discharge at those times. And then if you do choose to integrate the solar, all of a sudden you're running your diesel generator on rare occasion when you have high demand events. But again, it has a lot of flexibility to scale up and integrate what you need without it getting out of hand. So a lot of flexibility for these on-off grid applications here. And this is going to be a similar array setup where it will scale and grow into those different levels. I think I might have seen a question come through here. Check on this. Yeah, yeah, we will. I can definitely cover some of the domestic content stuff. Um, so the 261 is going to be manufactured out of our McKinney facility. We expect that to be done or to be in like first products off the line, I would say mid Q2 at this point. I think we're gonna have prototypes done by Q1. We'll have the first prototypes off the line, but in order for it to be finally like validated, signed off, and then fully operational, um, there's a lot of different components. I want to say the domestic content threshold. So there's a few different factors here. There's domestic content, there's FIOC, and there's BABA. Each of those have their own thresholds and gateways. FIOC, I believe, right now is at 60% FIOC compliant parts. And then domestic content is different because it's the requirement for the parts. I want to say it's 30 or 40%. Um, but it's 40% of domestic content. So parts made in America, not just not from FIOC concerned countries. So a lot of nuance in this. The components that we're looking at, we're getting domestic bent metal. So like the entire housings and structure is all going to be US made sheet metal. I think we've identified the liquid cooling systems as well. Then we might be working with some automotive manufacturers to get the liquid cooling systems in there. The EMS screens, the BMS, I think we're in the process of getting the boards fully manufactured here. And then we're doing full assembly here in the US. So all final assembly. Pretty much everything except for the cells we've been able to fully validate in terms of US domestic product. There is a few US cell manufacturers that we're considering. It's a bit of a stretch because there's so much demand there, and that technology and volume isn't really there, especially as lithium prices are continuing to increase as demand goes up with all of the EV car production. So that tends to be kind of an overview of what the different percentage breakdowns look like. All of our fire safety and suppression stuff is US made, so Again, yeah, we're hoping to have that domestic content percentage of 40 plus, because for FIOC, we need to be at that 60% threshold. And if we're doing FIOC anyways, we might as well get as many products from the US as possible. So in doing so, we'll help capture that. As a result, prices are going to be higher. So that's kind of the balancing game that we're playing right now. If you get a 30% tax credit from being domestic content, is our price going to be less than 30% more than our internationally purchased batteries. So we will be continuing to provide both. We will still continue to manufacture overseas and then ship in final products for those that are not as domestic content required, or we will do domestic manufacturing for, because there's a lot of like uh, grants or U.S. funding or government funding contracts that require BABA and FIOC in order to even receive the money to do the project in the first place. So those tend to be where the FIOC and BABA compliance stuff becomes the most critical, as well as domestic content. So yeah, all different factors. I think we're aiming for around the 40% threshold. So we hope to try and overshoot it a little bit so that we don't have to be the limiting factor and it actually gives buyers more flexibility on other components of the project. Hopefully that answers that question. Um, I appreciate you dropping in there. Feel free to do so. Any others? And just to kind of pick up where we left off in here, this is very similar to the other project, just now more off-grid in terms of utilization, having it broken down and structured in the right way so that each array and station supports some component of the entire load structure. And that, I think, yep, that does just about wrap up this webinar today. So, very much appreciate everybody's participation in this. Thank you very much for listening in. It's fun to being able to dive in a little bit more on a specific product, talk about the nuance and what makes it special. Happy to answer more questions. And thank you everybody for participating. It's been always a joy to deliver these and make sure that we have all the content we need. Encourage you to follow us on YouTube, on LinkedIn at Renon Power. Visit our website, renonpower.com. We've recently launched also Renon Academy. So if you navigate to our website, from the drop down, you should be able to navigate to Renon Academy, where you'll see this webinar posted, as well as all future webinars, and you'll see our timeline of upcoming webinars. Really encourage you to get registered, share your information, and we're excited to continue to grow as a brand. I think 2026 has a lot of fun stuff in store. So thank you everybody for participating, and we look forward to working with you guys more.